we have Dr. Nirmala Devi with us. So now I will read her brief profile for your information. Dr. L. Nirmala Devi received her BE, ME and PhD degrees in Electronics and Communication Engineering from the Department of Electronics and Communication Engineering, University of College of Engineering Autonomous, Osmania University, Hyderabad. She is currently working as a professor and head in the Department of Electronics and Communication Engineering, Osmania University, and also director CHW, Osmania University. She has teaching experience of more than 20 years in subjects like wireless communications, wireless sensor networks, IoT, and data and computer communications, digital signal processing, analog communication, digital communication, adaptive signal processing, and research methodology for engineering. Her research interests includes ad hoc networks, wireless communication, wireless sensor networks, IoT and signal processing, machine learning and AI. Currently, she is working on various research projects sponsored by Ministry of Electronics and Information Technology, Government of India, New Delhi, Department of Science and Technology, DST, and UGC. Recently, she has received a grant of 1 crore to work on Smart Cities project from RUSA 2.0, sponsored by MHRD, Government of India. She delivered keynote and invited talks at several international conferences and workshops. She has served as TPC member, organizing committee member of numerous international conferences, and conducted 2 GAIN programs, GAIN programs in the year 2017. She has presented her paper in IEEE flagship conference, International Conference on Communications at Shanghai. She has been selected for Outstanding Woman in Engineering Award during the annual Women's Meet AWM 2018 in the year 2018. She has published many papers in various national, international journals, including IEEE conferences. She is a member of IEEE, IEI, and OSA. This is a brief profile about today's speaker, Dr. Nirmala Devi garu. Madam, yeah, we are very happy. Now you are with us. As and when we request you, you accepted our invitation. Okay. Thank you, madam. Now you can take over the session.
Yeah, sure, please. Just a minute, I'm presenting. Okay.
Okay.
Yeah, just a minute. Okay.
Any problem, madam, for sharing screen?
No. I am just from pen drive. I'm copying. Just 1 minute.
The pen drive.
Or else I'm just searching on. It is in the laptop. Or 1 minute. Sir, are you able to see the screen?
Yes, madam. Yes.
Screen is okay, sir?
Okay, madam. You can
That is
proceed.
fine. Actually, yeah, after so many days again, I was copying from the pen drive.
Okay. No issues.
That was the problem. So, dear participants, I welcome all of you to the ATAL workshop. And I appreciate that Professor Narasimhulu Garu is conducting this kind of workshop is really a motivating factor for us. And whatever the means, sir was doing most of the workshops and other programs like this related to this. So as far as this is concerned, signal processing and related technologies, but nowadays, all the technologies, the state of the art technologies are in vertical technologies. In the name of the vertical technologies, they have been developed. So if we see that, we can't say that this is the signal processing, this is AI, ML, and this is robotics, this is autonomous navigation. So there is a vertical technologies application. So I thought that I can give you some overview of the role of signal processing in IoT basically, because nowadays, that everywhere we could able to see and hear that the Internet of Things and etc. But whatever the vertical technologies, if you take the artificial intelligence and machine learning, or your Internet of Things or Internet of everything, that is full of sensors. Sensors are nothing but your sensing technologies and signal processing and your all of your ANN and all these things. So we'll just have a look at the IoT concepts, where by 2020, 22.5 billion devices will be connected to the IoT, and compared to 6.6 billions in 2016. So by 2016 only, 6.6 billion devices have been connected, but you see the escalation that it by 2021 means this 2022 statistics still not received, but it is 21.6 billion devices have been connected so far. It is a great escalation. That is how the Internet of Things are catching up nowadays, and the technology has been developed. So, and by connecting, by processing, by analyzing the signals and data, it is able to do so many applications. Signal processing is playing a significant role in expanding the number of IoT technologies and applications. So if you see that any applications, any real-time applications and any real-time scenarios, normally you will see that without signals, you can't do anything, is it not? Maybe we are bifurcating the specializations like microwave, embedded systems, even the processing unit, your microprocessors, microcontrollers, FPGAs, system on chip, maybe compute, they are just entities like for computational capabilities, the entities which can have the computational capabilities. But the input is a signal, is it not? A signal can be an analog signal or a digital signal, but as we are all of us knowing that the Internet of Things is powered by internet, the with unique identity devices which have been connected. So let us see that. Let us see that what is an IoT is basically. So the interconnection of computing devices embedded in everyday objects via the internet, enabling them to send and receive data. So whenever we are sending and receiving data, the internet is the key component here. And here we are talking about Internet of Things. Two main things we need to understand: what is M2M communication and D2D communication. So here, as human beings, we have certain languages to talk, whereas the device to device communication or machine to machine communication is they talk to each other by sharing data and getting feedback based on that data and all other data that is being generated, analyzed, and acted on. So if you are observing the Internet of Things life cycle, suppose, the best example is the sensor. A sensor is nothing but if you are taking a camera is the sensor, a kind of sensor. So if you are taking the camera, so much of traffic data is captured by the camera, which is connected in a junction, any junction if you are taking in real-time scenario. So if we are taking per day or per week or per month, so much of data you are going to have. How many vehicles are passing through that particular junction at that particular point of time? So if you are going to collect the data, that is nothing but the dissemination of the data. Once the dissemination of the data is done, you're going to collect the data, then you are going to communicate. Suppose it has to be shifted to a server where the analysis can be done. What analysis you want exactly? So if you are taking a real-time scenario, like in such metropolitan cities like Delhi or Hyderabad or Bangalore, you want to analyze that what is the traffic density at a particular point of time. On Monday, what could be the traffic density and how it is distributed, and Tuesday or Wednesday or on Saturdays. If I am going to take the data and if I'm going to analyze by plotting or by writing a Python program, or a C++, or a MATLAB, anything, you use any programming language, you use any processor, but you are going to analysis the traffic data, and you are going to say that on Monday morning to evening, this is the traffic data, that is your analysis. And then, once you know that that particular route is very busy, or at that point of time, what could be the traffic, then you just divert it. That way you can solve your problem. So IoT is one of the tools which are going to solve your real-time scenarios. So how it works exactly, understanding with real-time scenarios. When we are doing research, or when we are talking about the technology must be in such a way that it must solve our real-time problems. Not that in terms of theory we are going to do the research, but it has to solve our real-time problem. Your car could detect an engine problem. Suppose you can schedule an appointment with your mechanic and let the manufacturer know about the problem in case it has happened in other engines too. Suppose he is having a data about when you are next servicing or a kind of thing, automatically he is going to check up from time to time. So you will be out of danger, and your smart home could know if you had a stressful work day, could play soothing music and offer soft lightning when you walk through the door. Suppose when you are coming from outside, and by means of sensors and automation, if we are just starting all the devices in your home, as soon as you are entering into home, you will feel very comfortable. So in all these examples, none of the devices are acting alone. They act in a coordinated manner. See, Internet of Things is not a new word, but the problem is when we are connecting number of devices. Internet of Things is not a single device. It is about the number of devices. When number of devices are getting connected, coordination is most important thing. So compatibility of the devices when you are connecting is most important. Because of there is no compatibility. It is something like this. If you are having a cadence tool, or if you are having a FPGA kit, you only VHDL you can run on a FPGA kit. Or I think nowadays, because of the new technologies, even MATLAB you can convert. Such kind of things only happened from few years back. Otherwise, FPGA you can use only VHDL. If you don't know VHDL, you only know MATLAB, you only know Python. Then this is not the compatible. That hardware, that software only. So there is non-compatibility is there. They are responding to and submitting data. The sensors in the car connected to the mechanic calendar and manufacturer's log. Smart home knows you had a long day because it is connected to your calendar. IoT makes your life better for consumer, cost effective for the business. So IoT has a potential to streamline our daily lives. So if I'm coming to the formal definition of an IoT, because if I'm asking anyone what is the IoT, they just say that Internet of Things means we are connecting number of devices by means of the internet. If you are going little deeper, a dynamic global network infrastructure with self-configuring capabilities based on standard interoperable communication protocols where physical and virtual things have identities, physical attributes, and virtual personalities, and use intelligent interfaces and are seamlessly integrated into the information network. often to communicate data associated with users and their environments. So the IoT is not a small network, it is a global infrastructure. This is a dynamic global infrastructure which is having self-configuring capabilities. And if I'm taking IoT applications, today's research is very demandable and commandable, where you can see in real-time scenarios like last 2 years, you could have already seen what is the pressure on the health system. So IoT as a part of the IoT, telemedicine also have been implemented. Healthcare is one of the important application, and wearable devices have come into the picture. That is because of the invention of your sensors only. People are wearing all the devices like to check your BP, check your sugar, heartbeats, and many more parameters like that. Then and there you can measure. You need not go to the hospital, and a nurse is not going to attend you, and then she measures and tells you that what is your BP level, sugar level, and heartbeats, and weight, and etc. parameters, whatever of your concentration. And from the home itself, you can have a consultation from the doctor of any specialty, and you can get the advice and medicines. Even further investigations, maybe you will be visiting the hospitals. So healthcare is one of the innovations and one of the revolution, we can say, as a result of the IoT. And environmental hazards, we know, because in summers a lot of rains are going to happen, and in rainy season it's very hot. So this is very, because of imbalance in the system. So because of environmental applications, we can address smart farming, smart agriculture. Smart agriculture is going to replace the conventional agriculture methods, and it is going to give you the huge yield, and it will really uplift the farming methods, and farmers are going to get benefited. And wild vegetation and climate change monitoring. See, as I said that, there is a vast change in a particular geographical region. If you take India only, southern side, we have different weather or climatic conditions, and north side, it is totally different in the same period of time, if you are considering. So those things, can be predicted easily by having your weather forecasting systems. So weather forecast systems are going to alert us that, and the coastal areas are going to be affected in a different way. So we have weather forecasting systems which are going to alert us time to time. Excuse me. And the best example of the IoT is the smart cities. Only few cities in the world have been designated as smart cities, like Vancouver in the Canada, and Washington DC, and New York in the USA, and some other places, some only particular cities in Africa. And India, such a populated country, it is hardly difficult for us to develop a smart city, because we cannot compare with the infrastructure, and it's very difficult for us. We don't have smart devices with us. Population is very high, infrastructure is very poor. Because of that, we may not able to have any kind of smart cities, but to some extent what we can have is, as a part of it, we can have the sum of the comforts of the smart cities. If you take the major problem in any of the metros is the traffic. Traffic, normally whatever the metros or the other cities in the world, if you are taking as a model cities, the underground is by means of the metros, it is covered. So most of the traffic are used using the public transportation system, where the traffic is in the underground. Very less number of people will be using the road. So there is alternative system, and as it is underground, you cannot see most of the density on the roads. That is one solution. And smart buildings. The smart building is nothing but in less space, if you are having more number of vertical structures, it is very difficult. In which floor what is happening, and something happens. It can be managed by having sensors, cameras, and other kind of technologies. And urban computing, traffic monitoring, as I said, that traffic monitoring is one of the best solution of the smart cities. If any city is able to manage traffic, that would be the best city. And security and emergency. Nowadays, you know that what is happening outside when we are going, security is most important. So this is also we are managing to some extent. Then one of the breakthrough of this 21st century is because of IoT, we could able to enjoy some of these comforts and commercial shopping systems and retails, like managing of warehouses and etc. is by means of sensors and IoT technologies. And industrial side, if you see that we are using smart grids and smart metering kind of things, so power can be saved, and automation of the systems is also happening, and infrastructure. Real-time performance, energy efficiency. See, if you want to fill your fuel, or if you want to have charge, you want to charge your system. So if you have smart infrastructures anywhere, any place, you can work from any place. You're sitting at airport, sitting at railway station, or sitting at some outside, but it is not possible a country like in India. So, but some places, that's what we see from the Western part, the comforts is something different. So these are some of the applications. And if you are seeing the characteristics of an IoT, IoT network, the Internet of Things network should be a dynamic and self-adapting. See, when the system is, when it is dynamic, the means it has to adapt to the real-time situations. As I said, that the same example of the traffic, in the early morning, 9 o'clock traffic is very heavy, 12 o'clock very less, then you need not have, the sensors can go to the sleep mode, so that the energy consumption, because the cameras are self-powered. Of course, nowadays, daytime you are going to use the solar panels are there by means of this. If you are observing at the traffic junctions, they all the cameras are powered by solar panels. So sometimes the power is supplied by the solar panels in the daytime, but the same power, whatever is saved in the battery, that must be utilized in the nights. So it has to adapt, in the morning, it must be on, in the evenings, the night vision camera must be on. It has to come depending upon the timings. That is nothing but your self-adapting characteristics. Then, integrated into information network. So whatever the networking is there, that must be integrated and self-configuring. See, if suppose depending upon the environmental conditions, the outside, if you are seeing the environment is very harsh, even though it is the harsh environmental conditions, you have to adapt to that. Suppose, outside environment is very cool, then you have to start your heaters automatically, or else depending upon the temperature escalations, if it is too cool outside, if it is too hot outside, then you have to on your ACs. This is self-configuring. And interoperable communication protocols, the machine-to-machine communication is only because of the protocols, communication protocols. If communication protocols are not there, there is no M2M communication, because as we are communicating in some of the common languages, English, whatever, any other languages throughout the world, the machine-to-machine communication is by sharing by means of the protocols. Protocols are nothing but the set of rules which are predefined and unique identity. So in the IoT, when we are transmitting the information, when we are receiving the information, when we are sharing the information, identity of the devices is very important. We could able to say that this device, in a network, suppose you have a camera, you have another node, another processor, another server, cloud is there. So all these things are the devices, will have their unique identity. So these are some of the characteristics of your IoT. That's what is this, and a physical design of IoT. So if we are getting into the what exactly and how physically the IoT is designed, the things of IoT is, we are talking about the Internet of Things. Internet of Things is, internet is fine. That is a technology through which we could able to communicate seamlessly. So what things of the things is nothing but here, the things in IoT usually refers to the IoT devices. So the enabling of the devices through internet, that is the things. Things is nothing but your devices, your mobile phone, your home automation, your whatever the devices at your home, if it is a home application, at your hospitals, whatever the devices in the hospital. So depending upon particular application, how many devices you are getting connected to. which have unique identities and can perform remote sensing, actuating, and monitoring capability. Remote sensing in the sense, by sitting in the office, if you could able to control the devices, your fridge, your TV, your geyser, etc., devices, whatever is there, your laptop and your server, anything at home, you are remotely accessing. By sitting in your car, if you could able to switch on all the lights and other devices of your home, that is called remote accessing. Actuating and monitoring capabilities is nothing but your those are known as your things. Those includes IoT interface for sensors. You need an interface. If you are taking any node, suppose in a wireless network, if you are taking any node, your node can be a sensor. If you are looking at a sensor as a node, if you are going more deeper into that, you are going to have the blocks like you will have, because the whatever the in environment, whatever signals are there, those are analog in nature. All of us know that the speech signal, whatever I am delivering, is a random signal. Then those signals are captured by our sensors, and you have a transducer, because transducer is the only device which is capable of capturing directly the analog quantities like pressure, temperature, humidity, any of such speed. So whatever the parameters of your interest can the transducers are going to sense that, and then you have a to D converter, then you have a transceiver, then you have a microcontroller. Those are some of the blocks of your sensor. So a sensor, if you are considering as a node, you are just inputting the signal, which is analog signal, but your A to D converter is converting into the digital form, because your microcontroller cannot handle your analog signal directly. So whatever it is once it is converted, your humidity, your temperature, your pH, your oxidation, your turbidity, whatever the parameter of your interest. So suppose whether it is a water monitoring system, these are the parameters. If you are taking weather forecasting, some other parameters. If you are, it is a car automation, you are going to have speed and etc. That kind of. But all these things are analog in nature. Your sensors are going to convert by means of your A to D converter to the digital signals, and those digital signals are processed by your controller, and controller will have a small memory also. Then you have a transceiver unit. Transceiver unit is it transmits the signals and receives also. So it is a transceiver. Then it is given to the next level. So that is nothing but IoT interfaces for sensors. So here we are using the interfaces for these kind of sensors: temperature sensor, pressure sensor, humidity sensor. Interfaces for internet connectivity. What for we are using these interfaces to connect to the, because okay, some quantity is received by the sensors and it is processed by your controller. Then it has to be communicated to the for the processing to the next level. That is by means of your, if it is a small distance, we can use your Zigbee or Bluetooth, or else you have to use the cloud. Or the most popular one is the Amazon cloud. Through cloud, we are sending the data to the server. Then your server is going to do the analysis that, if you are drawing on the x-axis and y-axis, the traffic distribution in hours. 9 means 9 o'clock, 12 o'clock, 6 o'clock, and then you have here January, February, March. If you are going for months, then weekly. So like that, you can have a graph over there. Any layman can understand that what is the at Monday at 6 o'clock, where is the highest traffic, where is the lowest traffic, how the traffic is distributed in your city. And memory and storage interfaces. As I said that these things are nothing but because so much of data. See here what we are doing. Whenever your sensors are sensing data, dissemination of the data is happening. Once the dissemination is nothing but lots of bundles of data is collected. So you need a memory or storage, and audio and video interfaces. Suppose you have audio supported devices, video supported devices like your cameras. You need another kind of interface to take those informations. And an IoT device can collect various types of data from the onboard or attached sensors. See, some devices are attached with cameras and some are not. Wherever the data is, the cameras are attached, the data is disseminated, such as temperature, humidity, light intensity, all these things are sensing through the sensors. And as I said, that it is converted and it is processed through controllers, and then it is transmitted to the next unit, next level. And if we are just looking at what are the blocks, roughly, a USB host and Ethernet will be there for the connectivity. Then your processor is just CPU, or it can be anything. Then you have audio video interfaces, HDMI, 3.5 mm audio or RCA video, or memory. You have NAND normal. It says, temporary kind of memories, because, once the bulk data is inputted, is it not for till that is reaching to the next level, it must be saved somewhere, is it not? So that is your memory unit. Then you have graphics, that is graphical GPU. Then you have storage interface like SD card, MMC, or STDIO. And out of this, you have another unit called IO interface for sensors and actuators and whatever the input output devices which you can connect to this IoT device, that is UART, SPI, I2C, and CAN. These kind of things you can get connected by IO. So if you are taking this, how exactly the communication is happening? That's nothing but through the IoT protocols. I said that M2M communication, and there is a thin line between the Internet of Things and the M2M communication. Machine to machine communication is nothing but, by 1970s, OSI has been started, that is Open System Interconnection Model. So when your source and destination two devices are there, or transmitter and receiver, whatever you call, are M2M, machine to machine communication. Then you have this side also, you are going to have OSI. In the OSI, we have 7 layers basically, but when it is mapped to the IoT protocol, basically that is your data and computer communication. What we do is through the 7 layers, we are just transmitting the data. Through the same layers, we are going to receive the data. So here also we have that first one is the physical layer. In the physical layer, normally you are going to have the raw data. Raw data is nothing but the data which is just converted from analog to the digital. That's what, signals are there. So if the input signals are not there, you cannot do further anything. Like, there's nothing to do with data link layer, network layer, transport layer, or the here, this is a four layer architecture. In the sense, the input from the physical layer is also there. So it's a 4 layer architecture. Normally, OSI is the 7 layer architecture. So if you see that the first one, that means in the physical layer is the starting point where, the data is different in the physical layer, and when it is going to the data link layer, it is different, and network layer, it is different. So coming to the second layer, the raw data is arranged in the terms of frames. The link layer protocols determine how the data is physically sent over the network physical layers. That is by means of a physical means copper wires, electrical cables, radio waves. This is the physically the data is. Then, the scope of the link layer is the last local network connection to which the host is attached. Host on the same link exchanges data packets over the link layer using the link layer protocol. Link layer determines how the packets are coded and signaled by the hardware device over the medium to which the host is attached. So what is happening here? Whatever the raw data is there, arranged in terms of frames, and the protocols, whatever we are using at the data link layer is 802.3 Ethernet. All of you might be knowing that. IEEE Ethernet is one of the LAN standards, IEEE standards in the local area network in the link layer. That is 802.3 is the Ethernet, 802.16 is the WiMAX technology, 802.11 standard is the Wi-Fi, which we are using, and 802.15.4 is LRWPAN, that is personal area networks. Apart from that, we also are communicating our signals by 2G, 3G, now 4G, and some cities already implemented 5G and LTE cellular networks. So coming to the link layer, so 802.Ethernet is a collection of wired Ethernet standards for the link layer. So in the physical form, it is actually, if you are taking, for example, 802.3 10 base 5 Ethernet, that uses coaxial cables. So earlier days we used to have coaxial cables, and for the Ethernet connections, where we are using even in switches. And standards provides the data rates from 10 megabits per second to 40 gigabits per second and higher. The shared medium in Ethernet can be a coaxial cable, twisted pair wire, or and an optical fiber. So mostly because optical fibers are communicating with higher speeds, 40 gigabits per second. Mostly nowadays the communication is all the wired communication is through the optical fiber. And if we are taking 802.2 Wi-Fi wireless fidelity, so mostly we are using the Wi-Fi technology. That is IEEE 802.3 is a collection of wireless local area networks. Standards including extensive descriptions of the link layer. If you see in the diagram, see the Wi-Fi access point, which is in our houses, in our offices, where your access point is getting connected to your smartphones, appliances, sensors, etc., etc. For example, if you are taking 802.11a operates at the 5 gigahertz band, 802.11b and 802.11g operates in the 2.4 gigahertz band, and AC operates in the 5G hertz. So this is your Wi-Fi and WiMAX. We see depending upon the application, we are see mostly for office and for our internet, we are using Wi-Fi technology, and 802.16 is WiMAX. 802.16 is a collection of wireless broadband and standards, including extensive descriptions for the link layer, also called a WiMAX technology. WiMAX standards provides a data rate of 1.5 megabits per second to 1.5 gigabits is very higher standard. The recent update provides the data rates 100 megabits per second for mobile stations. And if you are taking LRWPAN, somewhere, like personal area networks, we are using mostly 802.15.4 LRWPAN wireless personal area networks. This is a collection of standard for a low rate. Means mostly, wherever speed is not an important issue, at normal speeds the data can be sent, then we are going to prefer LRWPAN. These standards form the basis of specification for high level communication ZigBee. LRWPAN standard provide data rates for 40 kilobits per second. These standards provide low cost and low speed communications for power constrained devices. Where speed is not a constraint and power is most important, you are going to use the LRWPAN. And 2G, 3G, 4G mobile communications are different generations of the mobile communication standards. Second generation is 2G, including GSM and CDMA. Third generation includes UMTS and CDMA 2000. I think all of you know this. That is the reason I'm going a little faster. And fourth generation includes LTE. This is also there. Now we are talking about 5G. We want more and more faster data rates. That is the reason that we are slowly transforming from 4G to the 5G. Then in the network layer. So from the beginning to the physical layer to the data link layer, we are just the above layer is the physical layer, and the data link layer are known as the lower level layers. Even network layer, including network layer, but almost the data link layer is going to do whatever the work required for the network layer is done at the data link layer only. The network layer is responsible for sending the IP datagrams from the source network to the destination network. So the data is sent, whatever the data in terms of frames have been modified into packets. So in the network layer performs the host addressing and packet routing. So mostly the data is in the form of packets. So the packets will be designated by a particular host address, and so it is doing host addressing and the packet routing. The datagrams contain source and destination address, which are used to route them from the source to the destination across multiple networks. When you are talking about the networks, in a larger network, you will again have subnets. So always, networks are nothing but networks of networks. The only thing is, when you are routing the packets, we need to know that from where to where it has to be, from which source to which destination it has to reach is going to be mentioned. The address. Host identification is done using the hierarchy of IP addressing schemes such as IPv4 and IPv6. Internet Protocol version 4 and Internet Protocol version 6. IPv4 is the most deployed internet protocol that is used to identify the device is on a network. It uses 32-bit address. So when we are specifying the addressing, IPv4 is using 32-bit address. It can generate 4.29 into 10 power 19 address spaces. Whereas, for improved version of it is IPv6 is the newest version of the internet protocol and successor of IPv4. It uses 128-bit addresses scheme and it can produce 3.4 and 10 to the power 38 address spaces. So if you compare, it is the number of times low power wireless personal area networks bring IP protocol to the low power devices which have limited processing capabilities. It operates in the 2.4 gigahertz frequency range and it provides the data transfer rate of 50 kilobits per second. So in the network layer, mainly we are using the protocols like IPv4 and IPv6. If I'm going back to the same, the base diagram. So these are the IoT protocols where in the link layer, whatever I have mentioned, Ethernet, Wi-Fi, WiMAX, LRWPAN, and network layer, we are using IPv4, IPv6, and WPAN. And coming to the transport layer, it provides end-to-end message transfer capability and provides functions such as error control, segmentation, flow control, and congestion control. See, mostly, when we are okay in the network layer, the work is done through routing the packets. The packets means almost the information has sent to the other side, but we need to understand that whatever the data we are transferred is errorless, or what is the authenticity of the data is most important. That is taken care by the transportation layer. So that is nothing but there are, all of us know that mostly we have studied in the other means when in UG and some of you maybe in the PG, the error controlling techniques in some of the subjects, and we have segmentation also and flow control and congestion control. So flow control and congestion control are two different phenomena which are going to occur in the transport layer. And TCP is a connection oriented and stateful protocol. Actually, the most popular and widely used internet protocol is the TCP IP protocol. Now we could able to do this lecture and so many applications you are using. When you are starting your day and you are ending your day by the internet, whatever you are using, whatever the communications you are doing is by means of your TCP IP, that is transmission control protocol and internet protocol. It provides error detection capability. TCP IP is an acknowledgement based protocol where, whenever we are transmitting data, immediately the acknowledgement will be sent back. So you are going to have the verification that the same data has been received or not at the destination side. It ensures reliable transmissions of packets in order. So, when packets are routed, each packet is given a number, 1 to 10, 10 to 20, 20 to 100. This is the numbers are given to the packets and it must be received in the same order. Once the order is missed in the sense something has gone wrong, then again retransmission, it will call for a retransmission. And IP protocol deals with the sending packets. The flow control capability ensures that the rate at which the sender sends and the data is not too high for a receiver to process. So internet protocol especially deals with the sending of the packets, and UDP is a connectionless protocol. So whereas, contrary to the TCP is a connection oriented protocol, UDP is a connectionless protocol. It is a one-shot protocol. It is useful for time-sensitive applications. It is a transaction-oriented and stateless protocol. It does not provide guaranteed delivery, ordering of messages, and duplicate eliminations. Once that transmission is done, that's it. There is no feedback or there is no acknowledgement is sent from the receiver end or the destination end. So there is no check back. But where, fast transferring is important and reliability is less. Reliability is not so important. At that time only we prefer UDP, otherwise we go by TCP. And coming to the application layer, that is the topmost layer, it defines how the application interfaces with the lower layer protocols to send the data over the network. See, once your data, which is in the form of a raw data, zeros and ones, okay, the analog signals are interpreted in the form of the digital signals, that is zeros and ones, through your data link layer to the network layer to the transportation layer is sent to the application layer. How the application interfaces with the lower layer protocols to send the data over to the network, HTTP. HTTP is, all of us know that hypertext transfer protocols is the application layer protocol that forms the foundations of World Wide Web. So once you are just entering into your Google, you will type that http://www.google.com, whatever you want. The protocol follows a request response model where the client sends request to the server using the HTTP commands. It is a stateless protocol again. COAP is constrained application protocol, is an application layer protocol. For machine-to-machine applications, we activate COAP. It uses a client-server architecture where client communicates with server using connectionless datagrams. So mostly, faster way machine-to-machine communication is very faster. So we use the datagrams here. WebSockets protocol allows the full duplex communication. All of us know that what is full duplex. In a simplex operation at a time, source to destination or destination to source. Simplex. Duplex is simultaneously. That is full duplex. Communication over a single socket connections for sending messages between client and server on the same line at a time. Full duplex. MQTT is message queue telemetry transport is a lightweight message protocol based on. See, MQTT is the most prominent IoT protocol basically, which is based on the public subscribing model, and it uses a client server architecture where the clients connects onto the servers or MQTT broker and publishes the messages to topic on the server. And XMPP, extensible messaging and presence protocol, is a protocol for real-time communication and streaming of XML data between network entities. It powers wide range of applications including messaging, presence data. Then we have DDS, data distribution services, is the data centric middleware standard for device to device. So M2M communication also we have done, and D2D or machine to machine communication. So DDS is used for M2M or D2D. It uses a publish subscribe model. Publisher creates topics to which subscriber can be subscribed. AMQP's advanced message queuing protocols is open application layer protocol for business messaging. Very frequently we get from Axis Bank, HDFC that they are going to fix this AMQP protocol that every 1 hour you message to so and so. We don't know sometimes, from where messaging is happening. This is mostly used for business applications. And if you are going into the logical design of IoT and abstract representation of the entities and process without going into low-level specification of the implementations. So if I am going to the IoT functional block, an IoT system comprises of a number of functional blocks that provides the system the capabilities of identification, sensing, actuation, communication, and management. If you see that here, how the IoT functional blocks looks like. See, at the starting you have the device, then the top you have the application. In between some of the things also we have management, services, communication, and security. So management and security is two parallel things which are going to carry out, and services and communication is also other most important things. So whatever the data collected through the devices is by means of the management, services, communication, and security is sent to the applications top. So we are going to communicate in the IoT by means of 4 models, that is request response, publish subscribe, push pull, and exclusive pairs. I'm just skipping this because this is a little deeper. Okay, these are okay. So work socket based communication. Let us explore some things into the sensors. I think the participants, maybe some of the faculties who are already pursuing their PhDs, so mostly you might be using wireless sensors or sensors. So better you have some knowledge about the sensors. So WebSocket API allows bidirectional full duplex communication between client and server, which reduces network traffic and latency. Suitable for low latency and high throughput requirements, this WebSocket based communication. So actually, what is a sensor basically? Narasimhulu sir? How much time I have?
Another 5-10 minutes, madam. You can continue.
That's okay. That's okay. So I just want to interact with them because if they really need some help,
yes. Please.
Yeah. So sensor, it is a device that provides. See, when I was talking about sensor networks and the sensors as a part of the IoT network, I just explained you about the sensor. Sensor is a device that provides a usable output in response to a specified measurement. I said that We are measuring the physical quantities like pressure, temperature, and humidity. These are all the physical quantities we can measure with the sensors. The sensor attains a physical parameter and converts it into a signal suitable for processing. Example like electrical, mechanical, optical, the characteristics of any device or material to detect the presence of a particular physical quantity. So if you are seeing the actuators, an IoT device is made up of a physical object, that is things, plus controller. Controller is nothing but your how exactly the operations are going to happen, which we are equivalently calling it as a brain of an IoT, that is the controller, and sensors plus actuators. So when we are combinedly using the physical object means the things, controller, sensors, and actuators, and then you need a networks like internet. See, all these things are going to work when you are applying that, that is like oxygen, which is in your internet. An actuator is a machine component or system that moves or controls the mechanism of the system. Sensors in the device sense the environment, then control signals are generated for actuators. So if you see that how sensors and actuators are connected, sensors are one side, which are going to measure the temperature, for example. Then temperature is continuously measured, is it not? Because it is a continuous quantity. If I am saying that the y-axis is some degrees and x-axis is time. Time is nothing but we are just measuring continuously because it is an analog quantity. Then it is given to the controller, that is a decision marker. If temperature gets above certain level, then turn off the fan. So that is nothing else, no action. That is actuator. Actuator is going to apply whatever the depending upon the sensor data. So the decision maker is the controller over here. So in between to the sensor and actuator, there is a control which is doing the decision making. So what the controller is going to do exactly, once the temperature is crossing 40 degrees, you switch on the fan, otherwise fine. So this is the working of IoT devices and use of actuators basically. So the communication protocols are, communication protocols form the backbone of IoT system and enable network connectivity and coupling to applications. These protocols define the data exchange format and data encoding schemes for devices and routing packets from source to destination. Other functions of the protocols include sequence controlling, flow control, transmission of lost packets. This is also done by the protocols basically. And means actually, nowadays, if we could able to run some of the applications of IoT is because of the sensor networks only. So wireless sensor networks comprises of distributed devices with the sensors. So when you are considering a wireless networks, nodes are there, nodes can be your PC, your node can be a sensor. Whenever your node is a sensor, it is becoming a sensor network. This is used to monitor the environmental or physical conditions. AWSN consists of a number of end nodes, routers, and coordinator. End nodes have several sensors attached to them and can also act as routers. Routers are responsible for routing the data packets from each node to the coordinator. And the coordinator node collects the data from all the nodes coordinator and act as a gateway that connects the WSN to the internet. Once you are collecting from all the nodes the data through the gateway, you are just giving to the through the internet, you are giving to the application side. So I'm not going much deeper because I don't know whether you are able to. So Narasimhulu sir.
Madam.
Yeah. Shall I stop here? I just want to interact with them.
Yes, madam. Yeah, participants. Now you can interact with madam.
Yeah. Because so this is something okay. How much we are teaching is not important. What I mean to say is, because maybe some people are faculty are there, and some might be completed the research, some might be doing the research. I just want to stop share. So if you have any doubts regarding research in signal processing, in okay, here it is stop share. Okay, yeah. If you have any doubts in research or in signal processing or any other related areas, you can express your doubts. or if you are in the sleeping mode, it is fine.
Yeah, participant, please raise your questions.
Hello, good evening, ma'am.
Yeah. Please.
Ma'am, this is Mirza from Lord's Institute of Engineering and Technology.
Okay.
Ma'am, I want to ask whether IoT is related to the data science. Can we relate our research of IoT to the data
Yes.
science and
Sure.
we can go on in the deep?
Yeah. Because did you understand what the data science is about? Data science is nothing but suppose if you are taking applications like traffic is there, banking is there. In banking system, daily, because of online and offline transactions, so many transactions we are doing. Whenever we are making a transaction, data is dissemination of the data is happening or not? It is happening. Yes or no? You just consider
Yes,
that
ma'am.
one person is doing at least minimum 5 transactions a day. Okay. How many transactions you can say that in Hyderabad city by evening? How many transactions? Maybe lakhs of transactions. These transactions are nothing but data only, no? Yes
Yes,
or no?
ma'am. Yes, ma'am.
Okay. So lot of data, bundles of data is there. But when you want the information exactly, how to retrieve that data? Suppose, in one particular bank, if you take SBI, you have 1,000 customers, 1,000 into multiplied by 5,000 transactions per day, multiplied by 30 days, so much of information. And something has happened to some ex-customer, is it not? You just want to retrieve the data. In what way you have to retrieve? You need a program for that, no? That is what
Yes,
your
ma'am.
research is. Retrieving the
Okay.
data is crucial here. So we are using deep learning techniques. We are using supervised learning, unsupervised. What is suitable to retrieve the data? Retrieving data is one of the important. That is the reason data science is means it is nowadays. Everywhere we could able to see that it is catching the attention. And similarly, you take health system. Health system, so many tests is carried out, so much of data is there, so much of information, so many hospitals, whatever the data they are collecting. Okay, so many patients in a year, and you want again that patients have come up after 10 years. You want to retrieve the data. If they have records, it is so easy for them to carry out. No, you need not ask again. You take all this tests and etc. No, the
Yes,
automation
ma'am.
and data is if you are saving in that particular way. If I am going today to the hospital for some purpose, after 5 years I am going again, after 10 years I am going, because lifespan is going 50 to 70 years, and at
Correct,
any
ma'am.
point of time you need some medical assistance. And every time we are going that, okay, you take this test we are giving, yeah, the doctors are giving us, no? But
Yes,
if
ma'am.
you have your previous history, time will be saved, your money will be saved, and it is easy for them, is it not? For assessing what is the medical history of particular X candidate, for Y candidate, for some, is it not? Retrieving of the data is only happening through data science. So your data science, whatever the data they are collecting through the IoT, means remotely whatever we are collecting also. Nowadays, this, even if you are going for a test to Vijaya Diagnostics, they are sending soft copies. Earlier, you never had this, no? Means some time back.
Hard copy,
10
hard
years
copy.
back, if you see, yes. So even as a what do you say, as a patient, I am also saving all my reports, all soft copies. It is useful for us, when a book is given that is written and we will be keeping somewhere, it is lost. You are shifting something like that. Then where is your data? You don't have data. But what we are doing nowadays, we are keeping in our pen drive, we are keeping in our system. Wherever you are there, you are carrying that data. Is it not? For 6 months, 1 year, it is valid. After that, again, small test you are going to carry out. But major things, MRI, very frequently you can't do X-ray, MRI, those kind of things you can carry, is it not? And if it is so flexible that, see, if you take that, it is the systems, whatever we are doing, the wireless sensors and the actuators, then the IoT, then you are AI, ML, in that, whatever the techniques you are using, supervised, unsupervised, and, Federated learning is also there, one of the new thing, and all techniques we are using in the data science. Day by day, as the population is increasing, data management will become more and more crucial. Then they are just seeing that in simpler way, can we retrieve the data from so much of bundles of data is there. That is the reason people are talking about data mining is one technique which computer science people is most used, and big data we are talking about, and data science is most important. See, when you are want to access online, if you are not managing data properly, how can you access? Is it not?
Yes, ma'am. Difficult.
Yes. So, but when we are managing the data, what kind of data it is, where it is applied, and what kind of techniques must be used, there is a choice. Again, you must be very intelligent to make a choice. Which technique you must be. Meta heuristic algorithms are there. This AINN is there. Neural networks are there. Supervised learning is there. Unsupervised learning is there. Deep learning is there. We need to see, verify, you need to compare parallelly, and which is the best method. Optimization techniques are there. Meta heuristic algorithms are there. So we should make a choice between them. Even genetic algorithm is also vastly used. Okay.
Thank you, ma'am.
Yeah.
So we can go for this interdisciplinary research also, ma'am.
Sure. You will be landing there only. Afterwards, electronics and data science may be another branch. Nobody. Nowadays, only we are IoT is one specialization.
Okay,
You
ma'am.
may not see
Thank you.
mechanical, electrical. Be in Internet of Things, be in data science, be in electronics and IoT. These kind of specializations may come up.
Okay, ma'am. Thank you.
Any other queries, please?
Anything you can contact. I think you have my number, or else sir is going to provide, or you can have my email ID also, Nirmala Devi @Osmania.ac.in. We have also developed a prototype. Now also we are developing another prototype for the unmanned aerial vehicles for crop monitoring. That is autonomous navigation. That is a crop deterrent system we are developing using the drones. So it is again, we are not going to do something with the drones. We will try to apply we are trying to establish the communication to the drone which is flying to the ground. So this is how the research is going to be. If you don't have, yes, sir.
Yeah, please ask your questions, any. Otherwise, we can conclude.
I think in the chat box something they have written or what? Okay, good. Okay. If you could have asked me to teach, means sir has asked me to teach something related to signal processing. So I thought it is more relevant because nowadays our interest is growing towards IoT, towards AI and ML and neural networks and deep learning. These are certain things, even when I am teaching in the college, because this is one of the open elective for all specializations like electrical, civil, mechanical, computer science. Students are bulk, I have to teach for 100 and 120 students. So they're also finding very interesting.
Yes, madam. Now we can go.
Yes, sir.
Madam.
Yeah, you can, sir.
Yeah. So it is very interesting, and even I am also excited. Madam has explained very nicely about the IoT concepts using signal processing techniques. Hope my FDP participants got benefited. Certainly, they will remember Madam forever on this IoT concepts. Really, I'm very thankful as and when I asked you to take a session without any hesitation, you have accepted. Okay. On behalf of the participants, I thank you once again. Okay. Session is very interesting, madam. Thank you,
Thank
madam.
you, sir. Thank you so much, sir.
Yeah.
Thank
Now,
you all the participants for listening patiently. Thank you.
Thank you,
participants, now as a part of ATAL FDP, now you can take one online test. Our team will circulate you Google form. Already it is circulated in WhatsApp. Please take the test and submit, and we will note it down. And next week in offline also, you will be having one more test. Okay. After that, as usual, as per ATAL FDP, we will form 3 to 4 members as a group. Who you are supposed to submit one article to the reflection journal. Based on the test 1 and test 2 attendance and reflection journal, your certificate will be issued. Once you score 70% of minimum, you will be given certificate. Once you score more than 90%, then you will be given distinction certificate. Okay, so keeping in view this, please take the test and submit by today. Thank you all. Now, Rasool, now you can upload test now.
Yes, sir. I have circulated the link in ATAL FDP WhatsApp group.
Yeah. Now I think they can submit by 9:45 now.
Yes, sir. So we are giving only 30 minutes.
Yeah.
Or we can
Okay,
give
sir. I'm leaving, sir. Thank you.
Thank you, madam. Thank you, madam.
Thank you. Yeah.
Thank you, madam.
Thank you.
Yeah, participants, you can take 20 minutes or 30 minutes and take the test and fill the answers and submit, and it will reach to our email in the Excel form. And as I told you, minimum 80% attendance is a must. So for outstation patient participants and local participants, we request you please visit the college and have a wonderful sessions in offline. So how you have enjoyed sessions in the online, in the similar way, you may also enjoy sessions in offline. Professor Subbarao is coming from Srinidhi. He speaks on signal processing for 5G, and myself will give you a talk and talk on the concepts of orthogonality, which is a basis for all transforms. And Vardhaman College Principal Dr. Ravindra will come the realization and design of IR filters. From BITS Pilani, Professor Prabhakar Rao will come and teach you the design and realization of FIR filters. And Professor Ravi Kumar is coming from NIT Warangal. Okay. And ECL, Electronics Corporation of India, former AGM, Professor Bhujangarao is coming and talking you, discussing you on the mathematical tools for the continuous time and discrete time signals. Those who are wish to take the signals and systems signal processing, those lectures will be very useful. You can have the pedagogical skills. Okay, with these few words, okay, attendance is